All right, question 37, another rational equation. So we have right here x times x minus 3 over x plus 1. So we have some intercepts right here. We have x-intercept at 0, 0. And we have an x-intercept at 3, 0, because you set the numerator equal to 0. We have x times x minus 3 equal to 0, so x is equal to 0. And x minus 3 equal to 0, so x is equal to 3. Okay. You have a slant asymptote. You have a slant asymptote at, no, sorry, we will have a slant asymptote, but let's take off something easier. Vertical asymptote will be x equals to -1. Okay. Now, we know that's a slant asymptote because the power in the numerator is greater. Okay, so we would not have any horizontal asymptote. We did not cancel anything else on the function, so we would not have any holes. So our job is to basically find out what the slant asymptote is. Now, just a reminder, to find out the asymptote, you can do either, for this case, you can do either synthetic or long division. I guess synthetic would be a lot easier. So you have 1 and then -3, and do not forget the constant term right here, which is 0. And then you do x equals to -1. So you would just go ahead and do the synthetic division like this. Okay, and we do not care about the remainder. So we only care about these two numbers, which gives us the fact that it is x minus 4. Y equals to x minus 4, that is the slant asymptote. Now, I was a bit surprised actually that some students, they were not very familiar in drawing a linear line. That was a bit surprised. To me, I think I find that very surprising. So 1, 2, 3, 4. So x minus 4 means that you have slope of 1. And then you have a slope of 1. You have a y-intercept of -4. That's what x minus 4 is telling you. And now you can just go ahead and plot the line. So you have this. And you have this. Okay, that will be your graph. Now, and just to keep in mind, if you now you should always ask for you should think about if your graph is right or wrong by coming up with some x values just to check, just to have a quick check to see if you are okay. Like for example, I would be a little bit nervous if my graph over here is correct or not. So what I would do is to come up with a negative x value, say -2, for example. I would go ahead and think about x being -2 and just substitute in to the original function. And I'm just curious. I'm just curious to see if that is correct or not. And I would say, well, it is 4 and then plus 6, and that is -2 plus 1, and I've got 10 over -1, which is -10. And I'll be like, yeah, at -2, I got a point that is pretty low, and that confirms my graph that, yeah, my left portion of the graph being pretty low right here, that's a good, that's also a good confirmation. The other way to confirm the graph is this. If you don't draw it here, then you probably need to draw it here. But the problem is that we do not have any other x-intercepts. We just don't. If you draw it over here, you will have to create an additional x-intercept, but we cannot. So that the lack of x-intercept could also be a confirmation for you to say, oh wait, so you really don't have a portion of the graph that's being drawn above the x-axis to the left of the vertical asymptote. That's not possible. So this is the this would be the final sketch of the graph. So making sure that you know how to recognize the existence of slant asymptote, and also how to decide which part of the graph to draw your curves. So I would suggest you to be ready to find slant asymptotes and also to get ready to select graphs on the exam.